We want to find the equation of the tangent plane to the surface given by z at the point 2, 6, 18. Let's first look at this graphically. Our surface is graphed here in purple. This red point is the point of tangency, and this yellow plane is a tangent plane. So our goal here is to find the equation of this yellow tangent plane to the surface at this red point. So going back to our notes, we first want to write the equation of the surface in this form here, where we have a function of x, y, and z set equal to 0. We can do this by subtracting z on both sides of the equation. So big F of x, y, z would be equal to 3y times cosine of 6x minus 2y, and then minus z equals 0. Next, notice how the point of tangency is the point x sub 0, y sub 0, z sub 0. So for us, x sub 0 equals 2, y sub 0 equals 6, and z sub 0 equals 18. And here's the equation of our tangent plane. Remember, we can derive this by finding the dot product of the gradient of f evaluated at the point of tangency and the vector v, where vector v is any vector in the tangent plane. This is because the gradient of f is normal to the tangent plane at the point of tangency, and therefore it must be orthogonal to every vector v in the tangent plane. So the dot product must be 0. So notice how the components of our vector v, looking at the equation of the tangent plane, would be x minus x sub 0, y minus y sub 0, and z minus z sub 0. So the next step will be to find our partial derivatives and then evaluate them at the point of tangency. So to find the partial with respect to x, we'll treat y and z as constants and differentiate with respect to x. So when we find the derivative of 3y cosine of 6x minus 2y with respect to x, we would have 3y times negative sine of 6x minus 2y times the derivative of 6x minus 2y with respect to x, which would be 6, so times 6, and the derivative of z with respect to x would be 0. So let's go ahead and simplify this. We'd have negative 18y sine of 6x minus 2y. Now we want to evaluate this at the point of tangency. So the partial with respect to x at 2, 6, 18 would be equal to negative 18 times y, which is 6, times the sine of 6 times x, that's 6 times 2, minus 2 times y, but y is 6. So this worked out nice. We have negative 18 times 6 times sine 0, but sine 0 is equal to 0, so this product is 0. Now we'll find the partial with respect to y, so we'll treat x and z as constants. So to differentiate 3y cosine of 6x minus 2y with respect to y, we'll have to apply the product rule. So we have the first function 3y times the derivative of cosine 6x minus 2y with respect to y. So we'd have negative sine of 6x minus 2y times the derivative of 6x minus 2y with respect to y, that'd be negative 2, plus the second function, which is cosine of 6x minus 2y times the derivative of 3y with respect to y, that'd be 3. Then, of course, the derivative of z with respect to y would be 0. So let's go ahead and simplify here. We'd have negative 3y times negative 2, that's 6y, sine of 6x minus 2y, and then plus, here we have 3 cosine 6x minus 2y. Now we want to evaluate this at the point of tangency. So y is 6, so we have 6 times 6 times sine of, well, 6x minus 2y is going to end up being 0 again, because we have 6 times 2 minus 2 times 6. So we have sine 0, and then plus 3 times cosine. Again, this would be 0. So notice how sine 0 is 0. So we have 0 plus 3 times cosine 0. Cosine 0 was 1, so this equals 3. Finally, we have the partial with respect to z. So we're treating x and y as constants. So the derivative of this first term with respect to z would be 0. The derivative of negative z with respect to z would be negative 1. Which of course means the partial with respect to z at any point will be the constant negative 1. So now we can use the value of our partial derivatives and the point of tangency to determine the equation of our tangent plane. If the partial with respect to x at the point of tangency is 0, I'll go ahead and write that in. So we'd have 0 times the quantity x minus x sub 0, so we have x minus 2, and then plus the value of the partial with respect to y at the point of tangency, which is 3, so 3 times the quantity y minus y sub 0, that'd be y minus 6, and then plus the partial with respect to z at the point of tangency, which is negative 1, so we have minus 1 times the quantity z minus z sub 0, so we have z minus 18 equals 0. Let's go ahead and simplify this on the next slide. Well, of course, this first product would be 0, so we have 3 times the quantity y minus 6 minus 1 times the quantity z minus 18, or just minus the quantity z minus 18, equals 0. So if we were asked to give the equation of the plane in standard form, we'd be done. If we distribute and simplify, we would have the general form, but in our homework, we're asked to solve for z. So let's go ahead and distribute, simplify, and then solve for z. So if we distribute, we would have 3y minus 18 minus z plus 18 equals 0. Notice how the constants are opposites, so this would be 0. So we have 3y minus z equals 0. So this would be the general form. Solving for z, we would add z to both sides, giving us the equation z equals 3y. So this would be the equation of our tangent plane to our surface at the given point, which again, going back to our graph, is the equation of this yellow plane. I hope you found this helpful.